So today's video is all about the structure of the eye, and by the end of it you should know the structure of the eye and how the eye responds to different intensities or amounts of light entering the eye. This links into the bit we've just been doing on reflex actions, and it is a type of reflex action. But to start with, we are just going to concentrate on looking at the structure of the eye. So hopefully, if you manage to print off the sheets from the Show My Homework, you'll have those in front of you. If not, I'm afraid you're going to have to draw yourself a picture of the eye and label it. So here is what we're going to have a look at. Basically, in the next couple of lessons, we're going to have a look at how the structures of the eye relate to their function, including accommodation. So that's near or distant objects, and that will be next lesson. The adaptations to dim light, which is what we're going to look at today. So we talked about this before, about how the eye is a sense organ that contains receptors that are sensitive to light intensity and colour. And we have talked about how these are energy transducers, so they convert light energy into electrical energy. And the key things that you need to look at on the eye and be able to explain how their structure is related to their function is the retina, the optic nerve, the sclera, you might see it written down as the sclerotic layer, the cornea, the iris, the ciliary muscles, and the suspensory ligaments. We are going to talk about some other parts of the eye as well, and you're going to fill those in on the table, but those are the key ones that you need to know. So let's start off with having a look at the diagram of the eye. So if you've got any idea of any bits of the eye, and you should have done this, I believe, in physics, it might be worth just pausing the video and seeing if you can label these key parts of the eye. So what can you label on the eye? And then we're going to go through them, and then we're going to go through each different part, and we are going to write down a little bit about the function of each part. So let's start with number one. Number one, you should hopefully have labelled the pupil. I'm not going to talk a little bit about these now, I'm going to talk about them more in a second. Number two is the cornea. Number three is the iris. Number four is the ciliary body or ciliary muscles. Number five, which is the innermost layer, that is this innermost layer here, that is the retina. 6 is the optic nerve. 7 is the fovea. 8, so that's the second layer sitting behind the retina, is the choroid layer. 9 is the outermost layer of the eye, which is the sclera. 10 is the lens, and 11 are the suspensory ligaments. Now, the one thing on here that hasn't been labelled is this sort of black line here. That's your conjunctiva. If you've ever had that infected, that's where you've had conjunctivitis. And you get a very nasty red eye if you've got sort of bacterial infection in your conjunctiva. So if you've managed to print out the worksheet, you can fill in the table. If you haven't, you'll need to just jot down a little bit about each of the functions of these parts of the eye. So we are going to start with looking at each individual bit of the eye. This is just like a different diagram. This also shows us the vitreous humour, which sits inside. It's a jelly-like substance. At the front here you have the aqueous humour, which keeps the eye in shape. Okay, it's just sort of colour diagram of it. We also didn't mention the blind spot, this part here. The blind spot is where the optic nerve leaves the back of the eye, and you don't have any cones or rods there. But having two eyes means you're never completely blind if light hits your blind spot. So let's start by having a look at the cornea. So the cornea is this front part of the eye. It is colourless, so it allows light to pass through it. Okay, it is quite curved in shape. Alright, so the eye is not a complete sphere, the cornea bulges out, and it's very tough. So it's connected to the sclera, the sclerotic layer, which is white, but this is a sort of circle of colourless and transparent tissue, and its main job is to refract or bend the light as it enters. Now we'll do more about this next lesson. Basically, as light enters, it has to be bent. It has to be bent so that it can focus. So it comes in and it has to be bent so it can focus on the back here at the fovea. And it is the job of the cornea, it's the job of the cornea to do all of that refracting. So its main job is to refract that light as it comes through. And this is where most of the refraction takes place. What your lens does, which we'll come back to a little bit later, your lens sort of fine tunes that refraction. Most of the refraction is done by the cornea. So the function mainly is to refract light so that it focuses. Next up, we have the pupil. Now, it's hard to get, we talked about this before, we talked about reflex actions. And we've talked about how pupils get bigger and pupils get smaller. I get very cross and say, it's not the pupil, it's the iris. And it's a trick, because your pupil is just a hole. Okay, so your pupil is a hole in the centre of the iris. All right, it is just a hole. But because of the way the iris changes shape, then it can allow different amounts of light through. So its function is to allow light to pass through and then be focused on the back here at the retina. Next, we have the retina. Now this is the part, the very inner lining of the eye, and it contains all the light sensitive cells. So it contains the cones and the rods. So rods are sensitive to light intensity, so they are triggered by very low light intensities. And so if it's very dark, you won't be able to see in colour, but you'll see in black and white because it's your rods that are stimulated. And your cones are responsible for detecting colour. They detect red, green and blue coloured lights. And right in the fovea, at the back here of the retina, I'll talk about that more in a second, but there are only cones. Alright, there might be a few odd rods, but there's mainly only cones. It's the most sensitive part of your retina. So its function is to contain the light receptor cells, cones and rods to detect the light. And then, as I said earlier, they act as energy transducers, take that light energy, convert it into electrical energy, and then that message passes along the optic nerve to the brain, which then decides what to do about it. Okay? Interestingly, all diagrams of the eye, although they look like this, and you think it's a slice down through the eye, like if you were cutting down to the middle of your eye from the top of your head to your chin, they're actually not that. They have been taken in cross section, what we call transversely. So if you're sort of cutting from ear to ear and cutting through the eye. Remember what I said about reflex arcs? Well, this is how the optic nerves pass out. This is your right eye, and then this optic nerve would go out and go to the left side of your brain, and where your left eye would be here. I shall draw it badly, but I will. So this would be your left eye, and its optic nerve would go out and cross over and go to the brain that way. Okay, so your optic nerves come out and cross over at the back of the eye, which is what this is. So your optic nerve, bundle of sensory neurons at the back of the eye, and carries the impulses from the eye to the brain. Okay, so once they've collected all that information, passes out and goes through to the brain. And your brain, through intense, training and being told things and knowing things, that's how it interprets the information it receives. So it knows what it's looking at, and it can decide. If you ever put on a pair of upside down glasses, which you can get, or those sorts of things, then it can massively interfere with what your brain perceives. Right, so the fovea, as I've already said, is this intense part of the retina, only contains cones, lies directly opposite the centre of the pupil, and its job is it's your sharp central vision. So this is the best place in which you see things, right slap bang in the middle, through your pupil, through your, so right slap bang opposite here, okay, dead straight line, sharp central vision. That's the best place to see things when the light is entering directly straight into your eye. Then we have the ciliary muscles. Now, we're getting to slightly more complicated parts of the eye now. The ciliary muscles or ciliary body are a ring of muscle, and again, remember this is a two-dimensional diagram with a three-dimensional structure. So they're a ring of muscle that surround the lens. All right, so they surround the lens, and what they do is they contract and relax, and when they contract or when they relax, that has a knock-on effect onto the thickness of the lens. So their job is to alter the size of the lens. So the lens can go from being quite long and thin to being quite fat and round. And it's the ciliary muscles that are responsible for that. And we will do more about that next lesson. But for now, you have to think about how they control the lens. Now the suspensory ligaments, they are located here, and they are what attach the muscles of the ciliary body to the lens. Now if you remember anything from your year 8, ligaments do not stretch, okay? All right, they are nice and tight, so they when the muscles contract, when the muscles relax, they will either slacken or tighten, and that will allow the lens to change shape. And again, we'll do more about this next lesson. So the lens itself. The lens is this transparent biconcave, so it curves out on both sides, flexible disc. Okay, it's attached behind the iris by the suspensory ligaments of the ciliary body. It likes to be spherical. Okay, it likes to be, if you leave it sort of in its relaxed state, it'll sort of blob out into a sphere, but you can sort of pull on it and make it like a disc shape, but it does generally like to be a sphere. But we will do more about that next lesson. But it's completely transparent. Now, unfortunately, sometimes people can have lens replacements because you can get cataracts. And therefore you can have your lens replaced, okay, and that will be fine. So its job there is to focus light onto the retina. Okay, your iris. This is the coloured part of your eye. So it's pigmented, so it can be highly pigmented with a lot of melanin, it can be brown eyes. If it's got very little melanin in, it can have blue eyes. And basically its job is to change size, okay, so that it will alter the size of the pupil. So the iris changes size, and that has an impact on the size of the pupil. So we're going to talk about that a little bit later. So as I said there, its function is to control how much light enters the pupil. Sometimes the iris needs to be small, so the pupil is big, okay, and sometimes the iris needs to be big, so the pupil is small. We'll talk about that a bit later. Choroid layer. Now the choroid layer sits behind the retina, and the choroid layer has two main functions. It's highly vascularized, so it contains lots of blood vessels, lots of capillaries, and those capillaries are bringing oxygen and glucose to the retina, so the cells of the retina can get lots of glucose and lots of oxygen so that they can respire, release energy, because they're energy transducers, they need a lot of energy to function as well. And also the choroid layer contains lots of highly pigmented cells, so lots of black pigment sits in there, and what that does is that absorbs any excess light. So if the light that enters the eye isn't picked up by a cone or a rod, you don't want it just sort of reflecting around the eye. That would just make you very confused. So the highly pigmented layer of the choroid layer absorbs any excess light. Okay, right, now the sclera. The sclera, or sometimes referred to as a sclerotic layer, is the tough outer white part of the eye. It's the white of your eye. It's incredibly tough. It protects the eye from damage. It keeps the eye, all bits together inside of it. And it's incredibly good at its job. Okay, it does contain lots of little blood vessels. You can see them sometimes in the corners of your eye, and they can rupture. But generally, it's white, tough, and protects the eye from damage. So those are the main parts of the eye. what we're going to move on to look at now is how we control the amount of light that goes into the eye. So this is not focusing, okay, that's going to be dealt with next lesson. This is purely the pupil reflex, which we have talked about before and we've written about before when it came to looking at reflexes and reflex arcs. Okay, so if you go from light to dark or from dark to light, your iris changes shape, and what that does is that alters the size of the pupil accordingly, and therefore either lets more light in so you can see better or protects the eye if it's very light. So how it does this is you could, if you wanted to, all right, find somebody in the house, look at their eye and observe the size of their pupil. All right, you can cover your eyes with your hands for about 10 seconds, take the hand off and see what happens. Okay, so remember we talked about this. This is a reflex action, and it's to do with either allowing more light in or allowing stopping the eye getting damaged. Okay, so this is why this works. Your iris has two types of muscles. It has radial muscle fibers that radiate out from the edge of the iris all the way out, and it has circular muscle fibers which go round and round the iris. All muscles can do is contract. Please remember this, don't write in your exams, they contract and relax. All muscles can only do is contract. And when a muscle contracts, it gets shorter. So when these muscles here get shorter, they pull on this outer edge of the iris. They all get shorter, your iris gets smaller, and your pupil gets bigger. When the circular muscles contract, because muscles can only get shorter, when the circular muscles contract, this circle will get smaller and smaller, and they will all get smaller, and so therefore your pupil will get smaller and your iris will get bigger. Okay, this is completely involuntary. You don't have any control over this at all when you're just moving around from light to dark. It just happens. So on the second side of your worksheet, if you've managed to print it off, if you haven't, you can draw it up table with your book and fill it in. These are what happens. So in the light, we're going in somewhere light. Okay, so here's the light coming on. It's going to cause our pupil to get smaller and our iris to get bigger. Why has this happened? Well, the circular muscles have contracted. The radial muscles have relaxed. The iris gets larger. The pupil gets smaller. The pupil is now said to be constricted. And the main job of this is to protect the cells in the retina from being damaged. Okay, because too much bright light can cause blindness, it can cause quite a lot of damage. You've ever had a flash go off in your eye, or you've ever had walked out and inadvertently looked into the sun, which you should never do. Okay, you could damage the eye. We go into the dark. Okay, what happens now is those radial muscles are going to contract and the circular muscles are going to relax, and that's going to enlarge the pupil. The pupil is now said to be dilated. Okay. So, in the dark, the radial muscles contract, circular muscle relax, the pupil gets larger, well, that's smaller, the pupil gets larger. Oh, sorry, hang on a minute. That should say the iris gets larger. No, the pupil gets smaller. Right, ignore that. Pupil gets smaller. The iris gets smaller, the pupil gets larger. I'm sorry. The pupil is said to be dilated. This allows more light into the eye in low light levels. Okay, hopefully that bit at the end made sense. I will correct it on the PowerPoint, so you can go and have a look at the PowerPoint on Show My Homework if that didn't make sense. Okay, so you need to take away the parts of the eye, what they do, and what happens in the iris and the pupil when we go from light to dark or from dark to light. Thank you.